Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of the Sphinx Water Erosion Theory, evidence that Egypt's most famous monument is 10,000 years old. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. The Great Sphinx of Giza is dated by Egyptologists to approximately 2500 BC, carved during the reign of Pharaoh Khafre. That date is based on proximity to Khafre's pyramid, a damaged inscription, and the absence of any earlier historical reference. In 1991, a Boston University geologist named Robert Schoch stood before the Sphinx and noticed something that Egyptologists had either missed or dismissed. The erosion patterns carved into the body of the monument were not the patterns produced by wind and sand. They were the patterns produced by rainfall, deep vertical channels consistent with water running down exposed rock surfaces over an extended period. The problem is that the Sahara has not been wet enough to produce this kind of erosion since approximately 5000 BC at the latest. If the erosion on the Sphinx's body was caused by rainfall, the monument would need to be at least 7,000 years old, and possibly older. Schoch presented his analysis to the Geological Society of America in 1992. Geologists found the argument credible. Egyptologists did not. The debate has continued for over 3 decades without resolution, and it touches on something much larger than the age of a single statue. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the global puzzle of unexplained ancient construction, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. The sky was the original clock, calendar, and map. Before writing, before money, before cities, human beings looked up and organized their lives around what they saw. The position of the sun at solstice told them when to plant and when to harvest. The rising of specific stars marked the seasons. The phases of the moon governed ceremonial calendars in cultures from Ireland to India. Our ancestors were not casual observers of the night sky. They were meticulous, obsessive, and precise in a way that rivals modern astronomical science. This precision is encoded in stone at sites around the world. Newgrange in Ireland is aligned so precisely that sunlight enters its inner chamber only during the 5 days around the winter solstice, and it has done so every year for more than 5,000 years. The pyramids of Giza are oriented to true north with an accuracy of 0.05 degrees. Stonehenge tracks both the midsummer sunrise and the midwinter sunset, as well as the 18-6-year lunar cycle. These alignments are not accidental. They were engineered with mathematical precision by cultures we have long underestimated. What drove this obsession with celestial mechanics? Partly practical. Agriculture depends on knowing the seasons, but partly something more profound. Ancient cultures believed the sky was alive, that the movements of stars and planets determined the fates of kingdoms and harvests. In this worldview, encoding celestial cycles into permanent stone was not merely useful but sacred. The great monuments of the ancient world are, among other things, the most durable clocks ever built. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns, in science, demand explanation. With that foundation in place, Let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding the Sphinx Water Erosion Theory. Evidence that Egypt's most famous monument is 10,000 years old is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Great Sphinx of Giza stands 73 meters long and 20 meters high, carved from the limestone bedrock of the Giza Plateau. Conventional Egyptology dates it to the reign of Khafre, approximately 2500 BC, based on the Sphinx's proximity to Khafre's pyramid complex, a fragmentary inscription on the dream stele of Thutmose IV that may reference Khafre, and the general chronological framework of the Old Kingdom established from textual and archaeological sources. This single data point, if taken in isolation, might be set aside. Anomalies happen. Instruments malfunction. Researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered Robert Schoch, Associate Professor of Natural Sciences at Boston University, conducted a geological survey of the Sphinx in 1990 and published his findings in the Journal of the Geological Society of America in 1991. Schoch argued that the deep vertical channels visible on the body of the Sphinx and on the walls of the Sphinx enclosure, the rock-cut ditch surrounding the monument, were produced by precipitation weathering, not by wind and sand abrasion. Now, a skeptic might propose an alternative explanation for this. And that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. Precipitation weathering and wind weathering produce distinctly different erosion signatures in limestone. Water running down a vertical surface carves deep, rounded channels along natural fault lines in the rock. Wind-driven sand abrasion produces horizontal undercutting and smooth, beveled surfaces. Schoch identified the Sphinx body and enclosure walls as displaying precipitation-type erosion. The head of the Sphinx, he noted, showed different weathering, consistent with wind erosion, suggesting it was recarved at a later date. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the Sahara Desert, contrary to its current appearance, was significantly wetter during the African humid period, also known as the Green Sahara. Pollen cores, lake sediment records, and animal fossils confirm that the Sahara supported grasslands, lakes, and large fauna until approximately 3,500 to 2,500 BC, when the monsoon system retreated and the region desiccated. Before that transition, rainfall sufficient to produce Schoch's proposed erosion would have occurred regularly on the Giza Plateau. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of, if the erosion on the Sphinx body was caused by rainfall heavy enough to carve deep vertical channels, the monument would need to have been exposed to that rainfall for a substantial period. Schoch estimates this places the construction of the Sphinx's body, or at minimum, the initial carving of the enclosure walls, at between 7,000 and 5,000 BC during the African humid period. Some researchers, including John Anthony West, who first brought Schoch to Egypt, argue for dates as early as 10,000 BC. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. Zahi Hawass, former Secretary General of Egypt's Supreme Council of Antiquities, has been the most prominent opponent of Schoch's theory. Hawass argues the erosion is explained by wind and chemical weathering, specifically salt crystallization, and that the absence of any archaeological evidence for a 7000 BC Egyptian civilization capable of carving the Sphinx is a decisive objection. No tools, settlements, or artifacts from such a civilization have been found on the Giza Plateau. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological errors. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Sphinx Water Erosion Theory. Evidence that Egypt's most famous monument is 10,000 years old. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the Sphinx body was carved during a wet climatic period considerably earlier than 2500 BC. Robert Schoch places the date between 7000 and 5000 BC based on the rainfall required to produce the observed precipitation erosion. John Anthony West and later researchers extend this to 10,000 BC or earlier. This theory implies the existence of an organized society capable of large-scale stone carving in Egypt before the Neolithic period, a society that left no other confirmed archaeological trace. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the erosion patterns on the Sphinx and its enclosure are produced by wind and salt weathering, not rainfall. Zahi Hawass and Egyptologist Mark Lehner argue that salt crystallization within the limestone, drawing moisture from morning dew and occasional desert rain, combined with wind abrasion, can produce the vertical channels Schoch identifies as precipitation type. This is the mainstream Egyptological position, which holds the 2500 BC date as consistent with all available evidence. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that geologist K. Lalgori proposed in 1995 that the Sphinx erosion is primarily the result of salt exfoliation, a process by which salts crystallize within limestone pores, expanding and fracturing the rock surface, combined with the distinctive way in which hard and soft limestone layers on the Sphinx body respond differently to weathering. Gori's model does not require precipitation weathering and is consistent with a 2500 BC construction date. What is striking about this debate is not merely that experts disagree, that is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Sphinx Water Erosion Theory, evidence that Egypt's most famous monument is 10,000 years old, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes: Schoch presented his geological analysis to the Geological Society of America in 1992, where it was received with considerable interest by geologists who found his identification of precipitation weathering credible on geological grounds. The geological argument that the Sphinx enclosure walls show deep vertical erosion channels consistent with rainfall has not been definitively refuted on geological grounds, even by researchers who dispute the dating implications. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented. Paleoclimatic records from the Sahara confirm that the Giza region received substantially greater rainfall during the African humid period, approximately 11,000 to 5,000 years ago. Pollen cores from Egyptian oases and lake sediment records from the Sahara establish this wet period with confidence. This independently confirms that the climatic conditions Schoch's theory requires did exist in the region, though their duration and intensity at the Giza Plateau specifically remain debated. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the Sphinx enclosure walls, the rock-cut ditch into which the Sphinx body descends, show more extensive vertical erosion channels than the Sphinx body itself, which is consistent with the enclosure walls having been exposed to the weathering agent longer or more directly. No hieroglyphic inscription or primary historical document names the builder of the Sphinx. The dream stele of Thutmose IV, erected between the pores around 1400 BC, is damaged precisely where the name of the builder would appear. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Sphinx Water Erosion Theory, evidence that Egypt's most famous monument is 10,000 years old. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives, that would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Schoch published an expanded version of his theory in Forgotten Civilization in 2012, connecting the Sphinx's proposed age to his interpretation of Göbekli Tepe and other early Neolithic sites. Egyptologists remain almost universally opposed. The debate is asymmetric in an unusual way. The geological argument has not been fully refuted on geological grounds, while the archaeological argument that no 7000 BC Egyptian civilization is evidenced anywhere on the Giza Plateau remains powerful and unrebutted. Schoch's theory requires a lost civilization for which no physical evidence has been found. Whether the absence of that evidence reflects genuine absence or incomplete archaeology is the question at the heart of the debate, and it remains open. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Sphinx Water Erosion Theory, evidence that Egypt's most famous monument is 10,000 years old, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Sphinx ultimately reveals is not just a historical puzzle, it is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.